Okay, now we're going to start coordinate geometry. The first thing we learn is slope or gradient. We can have a slope, a positive slope which is going up, or a negative slope which is going down. Now the formula for the slope or gradient is the y step on the x step. Some people learn rise on run. So looking at an example here, we can see that the triangle here has a rise of 3 and a run of 2. So the slope is 3 divided by 2, as in shown in part A. Part B, the run is 5, the rise is -2 because it's a fall, not a rise, and you do rise on run, which is -2 on 5. For part C, it is a horizontal line. The rise is 0 and the run is 3. That's looking at this arrow here, they've gone across 3, and so 0 on 3 is 0. That makes sense because the slope of a horizontal line is 0. The slope is referring to the steepness, and we're saying it has 0 steepness. D is straight up, and that's undefined because if you do rise on run, the rise is 3, the run is 0, so you can't divide by 0, and that gives an error. We call it undefined. That's an undefined slope. Alright, let's see if you can get the answers to exercise 7C1. So you can just pause this and try them, and then come back and see if you've got the answers correct. Okay, here's the solution. 7C1, question 1. Just to highlight some problems that I often find with students is that they don't select the correct triangle. Take for example this first one in part A. You want to select this triangle here because it matches exactly on the grid on the corner of a square. So you can easily see the rise is 1 and the run is 3. Whereas some other student may have actually chosen a different triangle. That one's not a good one to choose. The run is easy, but it's difficult to read the rise because it looks like it's about 3/4 and we can't know exactly what that really is. So you choose a triangle where it intersects with the grid line very well. Okay, next is another, they show a different way of getting the slope. Rather than using rise on run, they use this formula here, y2 take y1 on x2 take x1. Now the reason why we can use that formula, over on the right hand side with this diagram, if you take point B is x2, y2. Now x2 is the distance along the x-axis, so that's this value here, that is x2. y2 is the distance along the y-axis, that is y2. So that means that the run, which is this bit here, has to be the difference between the y2 and for this point here, which is y1, the difference between y2 and y1 is going to be this, which is the rise. If we look at the run, that comes from the difference between the x2 and the x1. And the difference between the x2 and the x1 is this here, which we call the run. So it doesn't matter if you don't have that in the mind, all you do is have to use this formula. Because you've got a help sheet, you can just go into the test with the with the formula written down. It's best to see with an example. Here are 2 points, 1, 2, and we're going to call the first one x1 and y1. That's the first point. So it's x coordinate, y coordinate, x1, y1. The second point we call x2, y2. So that's for point 2, x2, y2. Now to find the gradient, we use the formula y2 take y1 on x2 take x1. y2 take y1 will be y2, this one, y2 take y1. So it's 4 take minus 2. 4 take minus 2. x2 take x1 will be this one, x2 take x1. 6 take 3. 6 take 3. 4 take 2 is 4 plus 2, which is 6. 6 take 3 is 3. 6 on 3 is 2. So we found out that the gradient or the slope is 2. Okay, now you can try using the formula method to do exercise 7C2. So if you pause this and then try those questions. And here's the solutions, 7C2, all of those answers there for the slope. Question 2 and question 3 you could do on the same set of axes, draw lines through that point with those gradients. You can pause that and have a go and then check the answers. The answers are here, 7C2, question 2 and question 3. Okay, now we're going to look at parallel lines and perpendicular lines. If you look at the parallel lines, it's easy to see the slope is the same because you have the same run. So that's run rise of 1, 3. Here we have a run of 1, rise of 3, so you're going to get the same slope. Perpendicular lines are a bit different. Let's have a look at this number here. This is 3 on 1. For the slope of line 1. Line 2 is perpendicular to it, and to get the slope you invert it and place a negative times by a negative. So instead of 3 on 1 it's 1 on 3 but with a negative. And the reason why is because if you look at line 1, let's say that this is the x-axis across here, and say this is the y-axis. Then let's take a point on this line 2 here. We could say that the coordinate of that is 3, minus 1. Now if you rotate that point by 90 degrees, that point comes all the way over to here. And the coordinate of that point is now minus 1, minus 3. Now the rise on the run is the y step on the x step. So for this case it's minus 1 on 3, but for this case here it's going to be minus 3 on minus 1. And minus 3 on minus 1, the minus and minus give a plus. So that's equal to 3 on 1, so we can compare that to this. You can see it's inverted and times by a negative. Okay, so you just have to remember that rule. You flip it upside down and times by a negative. We'll see with some numbers. So these are perpendicular. I'll start off a few. So 1 on 2. The perpendicular line would have a slope of 2 on 1 times by a negative, it would be minus 2 on 1. Okay, so I'll pause this. You can pause this and try those. Okay, here are the answers to 7C3. Question 1. Now the next set of questions is using slope or gradient in context. This is good because we can see the application. The first one is about a runner, and he is running for 60 seconds and he goes 400 meters, and the first question is find the gradient of the line. You can use any triangle to work out the rise and the run. You could use something like that. So the rise is 200, the run is 30, or you could use something like that, where the run is 400 and the rise is 400 and the run is 60. So if we used that triangle, rise is 400, run is 60, so we can say that the slope equals rise on run, 400 on 60, and on the calculator that would give roughly about 6.6, and that's in meters per second because the rise is in meters, 400 meters, the run is in seconds, and so your answer is meters per second. Now that's part A. Part B says interpret that, and that is a speed value. Meters per second is a speed. So the slope of a distance time graph is the speed. So that's how fast the runner is going. Every second he is going 6.6 meters. And C is the speed constant or variable. Well, it's constant because the slope is constant. If the slope's the speed, then if the slope's constant, then the speed's constant. Okay, now you can try the rest of 7D. So pause that now and come and see the answers later. Okay, so 7D, the answers are there for 1, 2, 3, 4 and 5.